On the canvas, the clearRect method takes 4 arguments, which set the position and size of the rectangle to be cleared. clearRect. On the canvas, the clearRect method takes 4 arguments, which set the position and size of the rectangle to be cleared. As with fillRect, the first 2 arguments represent the x and y coordinates of the top left corner of the rectangle, and the last 2 represent the width and height. Calling ctx.clearRect 0, 0, 200, 200 erases a 200 by 200 pixel rectangle, starting at the very top left corner of the canvas. Because our canvas is exactly 200 by 200 pixels, this will clear the entire canvas. ctx.fillRect position 0, 20, 20 pixel square at the point position 0. When our program starts, the square will be drawn at 0, 0. Because position starts offset to 0. Position, position, position. Get larger than 200 with the check if position 200. If it is, we reset it to 0. Set interval. Milliseconds, or about 33 times a second. This time interval is set by the second argument to set interval. At each time the supplied function is called, it clears the canvas, draws a square at position 0, and increments the variable position. As a result, the square gradually moves across the canvas. When the square reaches the end of the canvas 200 pixels to the right, its position is reset to 0. Figure 14:1 shows the first 4 steps of the animation, zoomed into the top left corner of the canvas. Figure 14:1. A close-up of the top left corner of the canvas for the first 4 steps of the animation. At each step, position is incremented by 1, and the square moves 1 pixel to the right. By making only 3 changes to the code in the previous section, we can create a square that grows larger instead of moving. Here's what that code would look like. var canvas equals document.getElement via canvas. var ctx equals canvas.getContext2d. var size equals 0. Set interval function. ctx.clearRect 0, 0, 200, 200. ctx.fillRect 0, 0, size, size, size. If size 200, size equals 0, 30. As you can see, we've done 2 things. First, instead of a position variable, we now have a variable named size, which will control the dimensions of the square. Second, instead of using this variable to set the square's horizontal position, we're using it to set the square's width and height with the code ctx.fillRect 0, 0, size, size. This will draw a square at the top left corner of the canvas, with the width and height both set to match size. Because size starts at 0, the square will start out invisible. The next time the function is called, size will be 1, so the square will be 1 pixel wide and tall. Each time the square is drawn, it grows a pixel wider and a pixel taller. When you run this code, you should see a square appear at the top left corner of the canvas and grow until it fills the entire canvas. Once it fills the entire canvas, that is, if size 200, the square will disappear and start growing again from the top left corner. Figure 14:2 shows a close-up of the top left corner of the canvas for the first 4 steps of this animation. Figure 14:2. In each step of this animation, size is incremented by 1 and the width and height of the square grow by 1 pixel. Now that we know how to move and grow objects on our screen, let's try something a bit more fun. Let's make a bee that flies randomly around the canvas. Well, draw our bee using a number of circles, like this. The animation will work very similarly to the moving square animation. Well, set a position, and then for every step of the animation, well, clear the canvas, draw the bee at that position, and modify the position. The difference is that to make the bee move randomly, we'll need to use more complex logic for updating the bee's position than we used for the square animation. We'll build up the code for this animation in a few sections. Circle. Bar circle. Equals function. X, Y, radius, fill circle. CTX.begin path. CTX.arcs, Y, radius, 0, math.pi. 2, false. If fill circle. CTX.fill. Else. CTX.stroke. The function takes 4 arguments x, y, radius, and fill circle. We used a similar circle function in chapter 13, but here we've added fill circle as an extra argument. When we call this function, this argument should be set to true or false, which determines whether the function draws a filled circle or just an outline. Inside the function, we use the arc method to create the circle with its center at the position x, y, and a radius of radius. After this, we check to see if the fill circle argument is true. If it is true, we fill the circle using ctx.fill. Otherwise, we outline the circle using ctx.stroke. Draw B. Draw B. Circle. To draw a bee at the coordinates specified by its x and y arguments, it looks like this. Bar draw B equals function x, y. CTX.lineWidth equals 2. CTX.strokeStyle equals black. CTX.fillStyle equals gold. Circles, y, 8, true. Circles, y, 8, false. Circles, 5, y, 11, 5, false. Circles, 5, y, 11, 5, false. Circles, 2, y, 1, 2, false. Circles, 2, y, 1, 2, false. In the first section of this code, we set the line width, strokes style, and fill style properties for our drawing. We set the line width to 2 pixels and the stroke style to black. This means that our outline circles, which we'll use for the bee's body, wings, and eyes, will have thick black borders. The fill style is set to gold, which will fill the circle for our bee body with a nice yellow color. In the second section of the code, we draw a series of circles to create our bee. Let's go through those one at a time. The first circle draws the bee's body using a filled circle with a center at the point x, y, and a radius of 8 pixels. Circles, y, 8, true. Because we set the fill style to gold, this circle will be filled in with yellow like so. This second circle draws a black outline around the bee's body that's the same size and in the same place as the first circle. Circles, y, 8, false. Added to the first circle, it looks like this. Next, we use circles to draw the bee's wings. The first wing is an outline circle with its center 5 pixels. Finally, we draw the eyes. The first one is 2 pixels to the left of the center of the body and 1 pixel above, with a radius of 2 pixels. The second one is the same, except it's 2 pixels right of center. Circles. 2, Y. 1, 2, false. Circles. 2, Y. 1, 2, false. Together, these circles create a V, with its body centered around the X, Y coordinate passed into the drawV function. Update. Appear to buzz around the canvas. The update function takes a single coordinate. We update the Z and Y coordinates one at a time so that the V will move randomly left and right and up and down. The update function looks like this. Var update equals function coordinate var offset equals math.random 4 to 2 coordinate equals offset. If coordinate 200 coordinate equals 200. If coordinate equals 0, return coordinate. Changing the coordinate with an offset value id, we create a variable called offset, which will determine how much to change the current coordinate. We generate the offset value by calculating math.random 4 to 2. This will give us a random number between 2 and 2. Here's how calling math.random on its own gives us a random number between 0 and 1, so math.random 4 produces a random number between 0 and 4. Then we subtract 2 to get a random number between 2 and 2. And we use coordinate equals offset to modify our coordinate with this offset number. If offset is a positive number, coordinate will increase, and if it's a negative number, coordinate will decrease. For example, if coordinate is set to 100 and offset is 1, then after we run the line id, coordinate will be 101. However, if coordinate is 100 and offset is -1, this would change coordinate to 99. Checking if the V reaches the edge and we prevent the V from leaving the canvas by making sure coordinate never increases above 200 or shrinks below 0. If coordinate gets bigger than 200, we set it back to 200. And if it goes below 0, we reset it to 0. Y equals updating. Circle. Draw V. Update. Buzzing V. Var canvas. Equals. Document. Get element vid. Canvas. Var ctx equals canvas.get context. 2D. Var x equals 100. Var y equals 100. Set interval. Function. ctx.clearRect 0, 0, 200, 200. Draw x, y. X equals update x. Y equals updating. ctx. Stroke rect. 0, 0, 200, 200. 30. As usual, we start with the var canvas and var ctx lines to get the drawing context. Next, we create the variables x and y and set both to 100. This sets the V's starting position at the point 100, 100, which puts it in the middle of the canvas, as shown in figure 14-3. Next we call set interval, passing a function to call every 30 milliseconds. Inside this function, the first thing we do is call clearRect to clear the canvas. Next, we draw the B at the point x, y. The first time the function is called, the B is drawn at the point 100, 100, as you can see in figure 14-3, and each time the function is called after that, it will draw the B at a new updated x, y position. Next we update the x and y values starting at t. The update function takes a number, adds a random number between 2 and 2 to it, and returns that updated number. S. The code x equals update x basically means change x by a small, random amount. Figure 14-3. The B drawn at the point 100, 100. Finally, we call stroke rect to draw a line around the edge of the canvas. Th. It makes it easier for us to see when the B is getting close to it. Without the border, the edge of the canvas is invisible. When you run this code, you should see the yellow B randomly buzz around the canvas. 5. Figure 14-4 shows a few frames from our animation. Figure 14-4. The random B animation. Draw ball. Objects created by the ball constructor can use it. Bar circle equals function x, y, radius, fill circle. ctx.begin path. ctx.arcs, y, radius, 0, math.pi. 2, false. If fill circle. ctx.fill. Else. ctx.stroke. Ball.prototype. Draw equals function circle this x this y 3 true. First we include our circle function, the same one we used earlier in a new circle function. We then add the draw method to ball.prototype. This method simply calls circle this.x, this.y, 3, true. To draw a circle, the circle's center will be at this.x, this.y, the location of the ball. It will have a radius of 3 pixels. We pass true as the final argument to tell the circle function to fill the circle. X, Y. Using the following move method. Ball.prototype. .move equals function this x equals this.x speed. This y equals this.y speed. We use this.x equals this.x speed to add the horizontal speed of the ball to this.x. Then this.y equals this.y speed adds the vertical speed to this.y. For example, at the beginning of the animation, the ball will be at the point 100, 100, with this.x speed set to -2 and this.y speed set to 3. When we call the move method, it subtracts 2 from the x value and adds 3 to the y value, which places the ball at the point 98, 103. This moves the ball's location to the left 2 pixels and down 3 pixels, as illustrated in figure 14-6. Figure 14-6. The first 3 steps of the animation, showing how the x and y properties change. The x speed or y speed property by negating it, multiplying it by 1. For example, if the ball hits the bottom wall, we negate this.y speed. So if this.y speed is 3, negating it will make it -3. If this.y speed is -3, negating it will set it back to 3. We'll call this method check collision. because it checks to see if the ball has collided with hit the wall. Ball.prototype .check collision equals function. If this x 200 this dot x speed equals this dot x speed. If this y 200 this dot y speed equals this dot y speed. And we determine whether the ball has hit the left wall or the right wall by checking to see if its x property is either less than 0 meaning it hit the left edge or greater than 200 meaning it hit the right edge. If either of these is true, the ball has started to move off the edge of the canvas, so we have to reverse its horizontal direction. We do this by setting this dot x speed equal to this dot x speed. For example, if this dot x speed was -2 and the ball hit the left wall, this dot x speed would become 2. And we do the same thing for the top and bottom walls. If this dot y is less than 0 or greater than 200, we know the ball has hit the top wall or the bottom wall, respectively. In that case, we set this dot y speed to be equal to this dot y speed. Figure 14-7 shows what happens when the ball hits the left wall. T. This dot x speed starts as -2, but after the collision it is changed to 2. However, this dot y speed remains unchanged at 3. Figure 14-7. How this dot x speed changes after a collision with the left wall. As you can see in figure 14-7, in this case the center of the ball goes off the edge of the canvas at step 3 when it collides with a wall. 2. Ring that step, part of the ball will disappear, but this happens so quickly that it's barely noticeable when the animation is running. The ball, and it uses set interval to call the methods that draw and update the ball for each animation step. Var canvas equals document.getElementVid canvas var ctx equals canvas.getContext 2D var ball equals new ball set interval function ctx.clearRect 0, 0, 200, 200 ball.draw ball.move ball.check collision ctx.strokeRect 0, 0, 200, 200 30. We get the canvas and drawing context as usual on the first 2 lines. Then we create a ball object using new ball and save it in the variable ball ed. Next, we call set interval ed, passing a function in the number 30 ed. As you've seen before, this means call this function every 30 milliseconds. The function we pass to set interval does several things. First, it clears the canvas, using ctx.clearRect 0, 0, 200, 200 ed. After this, it calls the draw, move, and check collision methods set on the ball object. The draw method draws the ball at its current x and y coordinates. The move method updates the position of the ball based on its x speed and y speed properties. Finally, the check collision method updates the direction of the ball, if it hits a wall. The last thing we do in the function pass to set interval is call ctx.strokeRect 0, 0, 200, 200 and to draw a line around the edge of the canvas, so we can see the walls the ball is hitting. When you run this code, the ball should immediately start moving down and to the left. It should hit the bottom wall first, and bounce up and to the left. It will continue to bounce around the canvas as long as you leave the browser window open. In this chapter, we combined our knowledge of animation from Chapter 11 with our knowledge of the canvas element to create various canvas-based animations. We began simply by moving and growing squares on the canvas. Next, we made a bee buzz randomly around the screen, and we ended with an animation of a bouncing ball. All of these animations work in basically the same way. We draw a shape of a particular size in a particular position, then we update that size or position, and then we clear the canvas and draw the shape again. For elements moving around a 2D canvas, we generally have to keep track of the x and y coordinates of the element. For the bee animation, we added or subtracted a random number from the z and y coordinates. For the bouncing ball, we added the current x speed and y speed to the x and y coordinates. In the next chapter, we'll add interactivity to our canvas, which will let us control what's drawn to the canvas using the keyboard. Here are some ways you can build on the bouncing ball animation from this chapter. 1. Bouncing the ball around a larger canvas. Our 200 by 200 pixel canvas is a bit small. What if you wanted to increase the canvas size to 400 by 400 pixels or some other arbitrary size? Instead of entering the width and height of the canvas manually throughout your program, you can create width and height variables and set the variables using the canvas object. Use the following code. Var width equals canvas width. Var height equals canvas height. Now if you use these variables throughout your program, you only have to change the properties on the canvas element in the HTML if you want to try out a new size. Try changing the size of the canvas to 500 pixels by 300 pixels. Does your program still work? 2. Randomizing this .speed and this .speed to make the animation more interesting. Set this .x speed and this .y speed to different random numbers between 5 and 5 in the ball constructor. 3. Animating more balls instead of creating just one ball. Create an empty array of balls, and use a for loop to add 10 balls to the array. Now, in the setInterval function, use a for loop to draw, move, and check collisions on each of the balls. For making the balls colorful, how about making some colored bouncing balls? Set a new property in the ball constructor called color and use it in the draw method. Use the pickRandomWord function from chapter 8 to give each ball a random color from this array. Var colors equals red, orange, yellow, green, blue, purple. Keyboard. Now,